This is the computer that we're going to be using for our experiments. This is a Raspberry Pi. This specific version is Raspberry Pi 4, and it's designated as the Model B. I don't think they made a Model A of the Raspberry Pi 4, but the last several iterations of the Raspberry Pi have said they're Model B. So this is the newest board that Raspberry Pi has put out. It's about the size of a credit card. The advantage of this board in the experiments that we're going to be performing is it's around $35. That's where it starts, so fairly inexpensive. And then it has all of the components on it to be able to act as a computer. So it's called a single board computer. Some of the key things, we'll talk a little bit more in detail of some of this stuff, but we have the CPU, or Central Processing Unit. We'll go into detail on what exactly that is. We have the RAM module. So the RAM is, it comes in a couple different variations of RAM. And we have USB connections. This is actually a USB 3.0 connection. There's an Ethernet connection. It has onboard Wi-Fi. There's a connection to be able to use a small HDMI cable to connect to two separate monitors, and they can actually be 4K monitors. So the board is very useful in doing experimentations with computer-controlled circuits. And that's kind of the reason that we're going down this route, and we're going to be talking about how this compares to a computer-controlled circuit that you might find on a vehicle. We'll briefly discuss some of the components that are found on the Pi and how we'll use those components in our electrical experiments. This unit here is the Central Processing Unit. You'll hear it referred to as a CPU. This is the actual computer part of this board. So the CPU processes the information that it receives. It carries out instructions. So if I wanted to turn something on, I might get information from a switch, and the CPU would get that signal from the switch that the switch is in the on position, and it would carry out instructions to maybe turn something else on. So I want to turn a light on when the switch is in the on position. So the CPU, you could think of it as the brains of the Raspberry Pi. Leaving the CPU, you can see those lines that are etched into the green board. Those lines are conductive, so it's just like a wire. It's just embedded into the material, and it allows an electrical signal to leave the CPU and connect to something, some peripheral. So it might connect to the RAM, it might connect to the audio, the video. The first thing that we care about is the connection that the CPU makes with the Gpio header. So the Gpio header is here at the top of the Raspberry Pi. It has 40 pins. Those pins are used to be able to connect or get a direct connection to the CPU itself. So from the CPU we follow a trace. The trace goes to a specific GPIO, and that's then we have access to interact with that pin. On the bottom of the board is a micro SD card slot. You put the operating system for the Pi on the micro SD card, and that's where it's stored. So it's not stored directly on the board itself. All the operating system and files that you save are stored on the SD card. So you could take that SD card and put it in a different Pi and have, you know, your operating system as well as all of your files associated with that. In a traditional computer, typically all the operating system and files are stored on a hard drive or a solid state drive. For expense purposes, you know, they eliminated that, and size, you know, those hard drive, even a solid state drive, is the size of a Raspberry Pi. So having the operating system on the SD card is going to save that space. If you go to that website that's listed here, you can download the Raspberry Pi operating system and install it on an SD card, and then plug it into a Pi and fire it up. The operating system is based on Linux, which is a operating system that's been around for a long time. Most manufacturing facilities and components and robots and most computers that are found on a vehicle will be running a version of Linux. And so Linux is an equivalent to think of Windows as an operating system or Mac OS. Let's take a brief look at what we're going to be trying to do here with the Raspberry Pi. Here I have a Raspberry Pi, just like the one that we're using in our computer. And then I have on the left this switch, and on the right I have a bulb. And at the bottom we're just looking at a power supply. So a Raspberry Pi is going to help us to be able to turn this light on. Now, a traditional electrical circuit you wouldn't even need the Raspberry Pi for. But we're going to talk about some of the advantages of using the Pi to be able to turn things on. So we'll just connect up some of these wires. So we just need to power up the Pi. The Pi is powered up through the USB-C port. And then here we have the light itself being powered up, and we've got to get a signal there to the switch. Alright, so the things that are happening on this screen, we're connecting to the GPIO pins. On the left, we're actually connecting and making that pin an input, and it's simply just a it's receiving an input whether or not that pin is grounded, because we connect directly to this negative terminal of the power supply. And when the pin is in the on position, it would, when the switch is in the on position, it would ground that pin. And when it's in the off position, it would not be grounded. So the Raspberry Pi is going to be able to monitor that. The right side is our output, so this bulb is connected directly to the positive terminal of this power supply. And then I have the wire that's going to a GPIO pin. Now the pins don't really matter, those might not even be the right pins, but the whole point is that we have a GPIO pin that can connect to something. And it can either be an input or an output, general purpose input or output. That side is the output. So what it would do is provide a ground to the bulb and turn the bulb on. And then the Pi itself, we have that central processing unit, that little silver square. That's where the decisions are being made. And then we have storage in the SD card. So those are kind of the four different areas of computer operations. We have an input, an output, processor, and some type of storage media, which is an SD card. So internally in the CPU, these are the things that are happening. In the CPU, we're monitoring a pin. So we monitor that input pin. And we've programmed, we've written code. Python code typically is what we run on Raspberry Pi. We've written Python code that is looking at the input. And right now it's getting us a state, and that state is in the off position. So it knows that the switch is in the off position. On the right side of this CPU diagram, we have the output. And once again, we're commanding that output to be in the off position based on the position of the switch. And then down at the bottom here, we have the logic. So this is just pseudocode, so it's not real code. It's just so we can help think through the logic. And the logic is that if the input is in the off position, then make the output in the off position. And then the other case is if the input is in the on position, then make the output, turn the output on. Okay, so we're going to get into the specifics of how to actually program that, but this gives us kind of the basics of understanding each component and each process in the build. So when I change that switch to the on position, the input now is on, and we're executing that second line of logic where if the input is on, then we want to turn the output on. So hopefully this gives us kind of a basis on why we'd add a CPU in there. Some of the advantages is we could change the input. The input could be many different things. It could be a potentiometer, some type of a light sensor. It could be any type of variable resistor, switches. It could be a momentary switch or a switch that is set, and a latching switch. And then the output, same thing, right? The output could be a light, a motor, really anything there. The CPU doesn't really care about what that is. The CPU is just executing instructions based on information that it's receiving. And so we'll kind of focus on that as we continue forward, talking about how we're going to use this Pi to understand inputs, outputs, and the processing.